All right. So the Pythagorean theorem and 45, 45, 90, 30, 60, 90 triangles. All right. What we see right now is we see a 45-degree angle right here, and we have 5 square root of 2 right here, and we're told that this is the altitude, so we should be good with that. So since this is a 45, 45, 90 triangle, and we have the hypotenuse, in your notebooks, I kind of told you to write this down the other day, so you should use this as reference, okay? If we're given the hypotenuse, which that's what we're given here, is a hypotenuse. The 5 square root of 2 is the hypotenuse. To get to the side, to go from the hypotenuse to the side, you divide by the square root of 2. So if we take 5 square root of 2 divided by the square root of 2, what happens? What happens? Just becomes 5. The square root of 2's cancel. We just get 5. So this is 5 and this is 5. So this is 5 and this is 5. Okay? Now, if we think about this big triangle, if this is 45, then this is 45, and all of a sudden we got another 45, 45, 90 triangle, right? So the two sides, these two sides are congruent to each other. So this is also 5 square root of 2, isn't it? So if this is 5 square root of 2 and this side's 5, then this side's 5. So AB is 10. Okay? So you got to know your facts for the Pythagorean theorem, where I like them in the order of c squared equals a squared plus b squared. Because then when we do the converse of the Pythagorean theorem, if you always write it with c on the left, and then we do the converse of the Pythagorean theorem, when c squared is bigger than a squared plus b squared, it's obtuse. If c squared equals a squared plus b squared, then it's right. And if c squared is less than a squared plus b squared, then it is acute. All right? So, here's a guy using a ladder. Now, the distance from the wall to the base of the ladder should be at least 1/4 the length of the ladder. He sets it up like that. Did he set it up correctly? Well, we'll see. We got to find out what the length of the ladder is. That is the what of this right triangle? A leg, short leg, long leg, or hypotenuse? Hypotenuse. That's hypotenuse. So that is C. So c squared equals a squared plus b squared. So c squared equals 2.5 squared plus 9 squared. 2.5 squared, I think, is 6.25. 9 squared is 81. So somebody with a calculator, take the square root of 87.25 on your calculator and see how long that is. The square root of 87.25. It's going to be 9 point something, but I don't know what it is exactly. $9.34. Sounds good to me. Now, it says, to satisfy safety regulations, the base of the ladder should be at least 1/4 the length of the ladder. Let's take 1/4 the length of this ladder. 1/4 times 9.34. Calculator, please. That's 2 point what? 1/4 times 9.34. 2.2 something? 2.34, 2.35, somewhere in there. So 2.5 is greater than 2.34. So yes, this does satisfy the safety regulations. Okay? So using Pythagorean theorem to solve a word problem. Due to safety requirements, a wheelchair ramp must have no more than 1 unit of rise for every 12 units of length. Does it meet requirements? Okay, so now what we have to do is figure out the length of this. So let's make that B. This is C because that's hypotenuse. Make this A. So C squared equals A squared plus B squared. So 500 squared equals 41 squared plus B squared. 500 squared is 25 with 4 zeros behind it. What's 41 squared? 8 something? No, 16. 16 what? 21? 1681 plus B squared. So if we subtract 1681 from here, it's 24 something. 24, 8, 3, 1, 9 equals B squared. Take the square root of that. It's going to be 400 and something. I would guess 490 something. 498. Okay? So, a wheelchair ramp must not have more than 1 unit of rise for every 12 units of length. So, this ratio of rise over run must be less than 112. So, you take 41 over 1 or 498 and let's just turn this into a decimal once. What's 41 divided by 498? 0.823. Take 1 divided by 12. What do you get? 0. Normal 83. No. 0.083 repeating. So this is the maximum it can be. This one is just slightly less than that. So yes, this does meet requirements because this is 1 to 12 ratio is this. This is what this ramp is rise over run, which is 0.823. It's less than this, so it meets requirement. Okay, 45, 45, 90. If you know the sides are S and S, the hypotenuse is S square root of 2. Or I would rather put on X and X and X square root of 2. I don't like S because it looks too much like a 5. Then, if you know just the hypotenuse, then you divide by the square root of 2 to get to the sides. So if you know the side, both sides are the same in a 45, 45, 90. These are always going to be the same. And then you're going to multiply by square root of 2. In a 45, 45, 90, if you have the hypotenuse, you divide by the square root of 2. Okay? If that is not written down somewhere, you need to have that written down. Okay? Hopefully it's in your notebook somewhere. Yes, it's up here, but, some of you may not be able to look at that when you're not in this room. So let's practice with 45, 45, 90. If this side is 7, what's XZ? 7, because the sides are the same. And then to get from the side to the hypotenuse, you multiply by square root of 2. So it's 7 square root of 2. Okay, it's 7 square root of 2. When you have the hypotenuse, to get to the side, you divide. So you take 12 square root of 2 divided by square root of 2. 12 square root of 2 divided by square root of 2 is what? Just plain simple 12. So if this side's 12, this side's 12. Because it's a 45, 45, 90 triangle. So problems like that aren't too hard. Okay? Because if you have a nice number here, this is a nice number, and you just multiply by the square root of 2. If this already has a square root of 2 in it, then you just divide so they become nice numbers. Where it gets a little more difficult is if you have like the square root of 6 out here. Okay, how do you get to here? Well, that's the hypotenuse of a 45, 45, 90 triangle. Okay, to go from the hypotenuse to the side, you divide by the square root of 2. So then it's square root of 3. Once you figure out this is a square root of 3, this is a square root of 3. Okay. All right, 30, 60, 90 triangles. Do they have? There it is. On a 30, 60, 90 triangle, once you know the short side, and again, I like to make it x. If you know the short side, you multiply by square root of 3 to get to the long leg. Not the longest side, but the long leg. And your hypotenuse is 2 times the short side. Now, if you're given the hypotenuse right at the start, you divide by 2 to get to the short leg. And then you take whatever the short leg is and multiply it by square root of 3 to get to the long leg. So you always want to find the short leg first, whether you're given this side or this side. If you don't have the short leg, find the short leg first. If you're given the short leg, it's easy. Just multiply by square root of 3, multiply by 2. If you don't have it, you have to get to here. So if you have the hypotenuse, you divide, and then you multiply. If you have the long leg, let's call that z. To get to the short leg, you divide by the square root of 3. And then you take that times 2. Okay? Whatever that is. So, always find the short leg first. So, let's go here. Short leg is 6. Well, if we're given 6, then that's easy. How do you get to the long leg? Multiply by the square root of 3. 6 square root of 3. How do you get to the hypotenuse? Multiply by 2. So you get 12. We're given the long leg. But the nice thing is they put the square root of 3 in the long leg. To get from the long leg to the short leg, we divide by square root of 3. So those cancel, so it's just 9. So when the short leg is a nice number, then you just multiply by 2 to get to the hypotenuse. Here, the hypotenuse is 26. What do you find first, the long leg or the short leg? Short leg. Always find the short leg first. Okay, so if we find the short leg, we get 13 here. Then how do you get from the short leg to the long leg? Multiply by square root of 3. Okay, that's a relationship for 30, 60, 90. Okay, so if this is 10 foot long, what's the short leg? 5. And the long leg? 5 square root of 3. Now, Alejandro wants to make horizontal and vertical supports for a ramp. Is one 12-foot long enough to make both supports? Well, somebody take 5 square root of 3 or 5 times the square root of 3 and change this into a decimal. What is that as a decimal? 5 times square root of 3. 7 point, it's 8 point something. 8.7. I got to take this one. That's the activity association. I'll be right back. Hello, Mr. Soma. Nope. Wrong one. It's Marcia. Good, good. Yes, I am. Okay, sounds good. And then I should be getting a contract for Watertown as the administrator. Randy said he'd get one out to me, and he's never gotten one out. Yeah, as an admin. Yeah. So, yeah, that sounds good. Yeah, that's the one in Watertown because I'm an admin, not reffing. Because, yeah. All right. Thanks. All right. Thanks. Bye. All right. Okay, so what's 5 plus 8.7? 13.7. Will 12-foot long board work? No, it will not work. All right. This one, Olivia starts an origami paper crane by making the 200 millimeter diagonal fold. What's her side length of that square? What? No. This is 200. We want to know this. So what we have to do, this is a 45, 45, 90, so we have to take 200 divided by what? When we square root of 2, we divide by the square root of 2, because when we go from the hypotenuse to the side of a 45, 45, 90, we divide by the square root of 2. So then you multiply top and bottom by square root of 2. So it's 200 square root of 2 over 2. And then 200 divided by 2 is 100 square root of 2. And now let's change this into a decimal once, just to see what the decimal equivalent is. This is the exact answer. So if they're asking for an exact answer, you use a radical. If they're asking for a decimal rounded to the nearest tenth, let's just round to the nearest tenth. What do we get? 141.4. Okay? So that's how many millimeters the side should be. Okay? All right, this one is a hard one. If they throw something like this at you, people struggle with this because of the numbers involved. Now, they're really not very nice when they give you a 28 there, but we're going to do it in case they do. So, to get from the long leg of a 30, 60, 90 to a short leg of a 30, 60, 90, what do? Divide by the square root of 3. Can't divide that, so we have to, and we can't leave a square root in the denominator. So we have to multiply top and bottom by square root of 3. So you get 28 square root of 3 over what? 3. Now, most of the time, they give you numbers where this is divisible by 3 and we reduce it down, and it's a little nicer. This one, it's not. So you're just stuck with 28 square root of 3 over 3 as an answer. Okay. How do you get from the short leg to the hypotenuse? Multiply by 2. So then just take the top part, 28 times 2, and you get 56 square root of 3 over 3. And that will be the answers that you put in. Okay? So be careful. There might be one kind of like that where you get crazy fractions. A couple of your ones on the worksheets were not very nice fractions, and it is what it is. You just have to go with what you have. Okay? This one's not that bad, but we're going to still, have to have fractions involved. This is 14. How do we get to the side? Divide by what? Square root of 2. So you multiply top and bottom by square root of 2. So it's 14 square root of 2 over 2, which is 7 square root of 2. So this one, if this would have been an odd number, then you'd have the kind of a weird fraction. But because 14 divides by 2, then it's just 7 square root of 2, not 3, 2 for each of those. Okay? All right. Feeling a little more comfortable with this now? Okay. So today, you're lucky. Just one Savvas lesson. That's it. On Wednesday, we're going to have a quiz over 30, 60, 90, 45, 45, 90, and move on to trigonometry, which again, a little more difficult. We'll spend a couple days on it. Okay? Miss Wheeldryer and I decided that we are just going to totally skip chapter 9 because that's kind of a weird chapter, and we'll come back to it at the end of the school year with some lessons. But so we're going to spend more time on this so you get this stuff down. before you have me in trig. So there you go. That's what we got going on today, is one Savvas lesson.